Hello everyone. My name is Dr. Aradhna Sahu, Associate Professor, Computer Science and Engineering Department from Sri Santosh Rungta Group of Institution, Rungta College of Engineering and Technology, Bhilai, Chhattisgarh. In our last video lecture of image compression, we have discussed some of the techniques used for compression. We are going to discuss JPEG compression, which is lossy compression, as some data is lost in the end. Let us discuss first what image compression is. Basically, image compression is the method of data compression on digital images. The main objective of image compression is to store the data in an efficient form and transmit the data in an efficient form. The image compression can be lossy and lossless. Moving towards the introduction and basic concept of JPEG algorithm. JPEG or JPEG stands Joint Photographic Expert Group. It is one of the most widely used image compression formats. Throughout this lecture, we will explore the principle behind JPEG expression and how it reduces the file size of images while preserving visual quality. It is an image compression standard which was developed by Joint Photographic Expert Group in 1992. It was accepted as an international standard. It is a lossy compression algorithm that results in significantly smaller file sizes with little to no perceptible impact on picture quality and resolutions. A JPEG compression images can be 10 times smaller than original one. This format is most common image format used by digital cameras and other photographic image capture devices, and it is also used to store and transmit photographic images to the World Wide Web. So before going to start encoding process, we will understand first why JPEG compression is used. JPEG uses transform coding. It is largely based on following observation. The first observation is large majority of usual contents change relatively slowly across images, that is unusual for intensity values to alter up and down for small areas. Second observation is when experiments suggested that humans are more immune to loss of higher spatial frequency component than loss of lower frequency components. The human vision is intensive to high frequency component. So first, let us take a look at an overview of steps that JPEG takes when compression and images. This technique follows a multi-steps processing involving several key techniques as seen in the diagram of steps of the JPEG compression. In this algorithm, first we will perform color transform and then downsampling. After the downsampling, the algorithm will apply DCT, discrete cosine transform method, for coding transformation. Then after, it allows a trade-off between storage size and the degree of compression can be adjusted. When perform the quantization, we will learn the human eye is not very good at perceiving high frequency element in an image. In this step, JPEG removes of the high frequency information without affecting and perceived quality of the image. The final step is entropy encoding. It uses RLE and Huffman encoding techniques to compress the files. These two techniques is already discussed in the detail on my previous video lecture of the different techniques for image compression. So, let us understand JPEG encoding process in detail. The first step for splitting and color space transformation. In splitting steps, the input image is divided into a small block which is having 8 cross 8 dimension in each block. This dimension is sum up to 64 units and each unit is the image is called pixel as shown in figure 1. Then it will go to perform color space transformation. The color space is specific organizations of colors RGB, that is red, green and blue, and CMYK, that is cyan, magenta, yellow and key black color are the example of color space. Moreover, each pixel in a picture has its color space value as shown in figure. But the human eye is more sensitive to brightness than color. Therefore, the algorithm can exploit these by making significant changes to the picture's color information without affecting the picture's perceived quality. To do this, JPEG first changed the picture's color space from RGB model to YCBCR model. YCBCR model consists of three different color channels. Y is the luminance channel containing brightness information and CB and CR are chrominance blue and chrominance red channel containing color information. In this color space, JPEG can make changes to chrominance channel to change the image's color information without affecting the brightness information that is located in luminance channel. After conversion, each pixel has three new values that represent the luminance, the chrominance blue and the chrominance red information. Now, step 3, it is downsampling. After we separate the color information from the brightness information, JPEG downsamples the chrominance channel to a quarter to their original size. So, each block of 4 pixels is averaged into a single color value for all 4 pixels. As a result, some information is lost and the size of picture is halved. But since the human eye is not very sensitive to color, the changes are not easily distinguishable. It is important to note that downsampling is only applied to the chrominance channel and the luminance channel keeps its original data. It is the reduction in spatial resolution while keeping the same two-dimensional representation, and it is typically used to reduce the storage and or transmission requirement of images. In the downsampling technique, the number of pixels in a given image is reduced depending on the sampling frequency. Due to this, the resolution and the size of image decreases. Conventionally, digital color images are represented by setting specific values of the color space coordinate for each pixel. The color space with decoupled luminance and chrominance coordinates allows the number of bits required for acceptable color description of an image to be reduced. This reduction is based on greater sensitivity of the human eye to changes in luminance than to changes in chrominance. The idea behind this approach is to set individual value of the luminance component to each pixel while assigning the some color chrominance component to certain group of pixel, sometimes is also called macro pixels. In accordance with some specific rules, this process is called downsampling, and there are different sampling formats depending on underlying scheme. The sampling formats are supported by Intel IPP image processing functions. The formats of sampling are: first, YUV 444. It is a conventional format. Here, no downsampling. The components are sampled at every pixel. If each components take 8 bits, then every pixel requires 24 bit. Second sampling standard is YUV 422, uses the 2:1 horizontal downsampling. It means that Y component is sampled at each pixel, while U means CB and Y means CR components are sampled every 2 pixel in horizontal direction. If each component takes 8 bit, the pair of pixel require 32 bit. We can see it in the figure. Now third sampling ratio is YCBCR 411. It uses the 4:1 horizontal downsampling. It means that Y component is sampled at each pixel, while CB and CR components are sampled every 4 pixels horizontally. If each component takes 8 bit, so each 4 horizontal pixel require 48 bits. Last sampling rate is YUV 420, uses the 2:1 horizontal sampling and 2:1 vertical sampling. Y is sampled at each pixel and CB and CR are sampled at every block of 2x2 pixel. If each component takes 8 bit, so each 4 pixel block requires 48 bit. So JPEG compression technique mostly uses 4:2 horizontal sampling. After the downsampling, the pixels data of each channel is divided into 8x8 blocks of 64 pixels. From now on, the algorithm processes each block of pixel independently. Now, this algorithm performs the step 4, that is forward DCT, discrete cosine transform. In this process, each pixel's value for each channel is subtracted by 128 to make the value range from -128 to +127. The color code between from black color to white color. This is shown in figure. Using DCT for each channel, each block of 64 pixel can be reconstructed and multiplied a constant set of base images by their corresponding weight values and then summing them up together. Applying forward DCT on each block of 64 pixel gives us a matrix containing the corresponding weight value of each base image. These values show how much of each base image is used to reconstruct the original 8x8 pixel block. Let us take an example to understand. Here we consider 8x8 image contains values. So this matrix of having integer of an image as shown in figure. The range of pixel intensities in each block is now 0 to 255. For compression, we will change the range from minus 128 to plus 127 because we need to compress the file. So just subtracting 128 from each pixel value, we got the result as the new matrix as shown in table. The DCT is performed on this n cross n square matrix of pixel value and it yields n cross n square matrix of frequency coefficient. In practice, n most often equal 8 because a large block through would probably give better compression. Often takes a great deal of time to perform DCT calculation, creating an unreasonable trade-off. As a result, DCT implementations typically break the images down into manageable 8 cross 8 blocks. But DCT formula looks somewhat intimidating as first glance. It can be implemented with relatively straightforward piece of code using some programming tool like Python as shown in figure. The result come out from this is stored in, let's say, in two-dimensional matrix, let's say di of j. There is a standard matrix that is used to computing JPEG compression. Then algorithm performs the quantization process. In this process of reducing the number of bits needed to store an image value by reducing the precision of integer. For quantization, this is using a separate quantization matrix which is given by a matrix called as luminance matrix. Here we can take some pre-calculated or default quantization table for processing as shown in table. To do this, the weight matrix is divided by pre-calculated quantization table and the result are rounded to the closest integer as shown in equations. In this case, the human eye is not very good to perceive high frequency elements in an image. In this step, JPEG removes of this high frequency information without affecting the perceived quality of the image. For every element position in DCT matrix, a corresponding value in the quantization matrix give a quantum value. It is indicating that what the step size is going to be that element. The coefficient that are most significant to the compressed interpretation of the image closer to the upper left corner are encoded with a small step size, while coefficients that are less important, those closer to the lower right corner, are encoded with the larger step size. The actual formula for quantization is as shown in equation of quantization. From the formula, one can notice that smaller DCT coefficient of high frequency elements divided by larger quantum values will most often result in the high frequency coefficient being rounded down to the zero. So, the sample matrix shows the effect of quantization on a DCT matrix. After applying this formula, we will get this matrix as shown in figure. Did you observe that the round on the right bottom area get 0 here? Now, we will perform the red brick which is done in JPEG compression. This is zigzag movement. This keeps all zeros together. The process of zigzag method is shown in figure. After zigzag scanning, we get a one-dimensional list of integer values, and after running run length encoding RLE on the list, we get each number and how many times there are repeated like in the following manner. It is shown in figure. How zigzag scanning is going on? See here, if we take first value from matrix, that is minus 26, the first you have to perform zigzag until you find all these zeros. So in this case, we have not found any zero before minus 26, and if we want to represent 26 in binary, then it will take 5 bits of binary. So it will represent minus 26 to 0, 5 in the bracket and minus 26, and all the number will follow the same manner until you find all 0 hits. So this is the final product after run length encoding. Finally, JPEG runs Huffman encoding on the result, and the value that have more frequency like the 0 are represented with fewer bits than less frequent values. Hence, our image is now compressed. So, this is the complete process of JPEG encoding process. And whenever we open a JPEG file using an image viewer or any other tool, the file needs to decode before it can be displayed. To decode the JPEG image, the image viewer tool does all the encoding steps in reverse order. The first step, run Huffman decoding on the file data. Then it will deconstruct RLE technique. The third step is put the list of numbers into an 8 cross 8 matrix. Then multiply the integer values by their corresponding quantization table. Then multiply the weight value by their corresponding base images. Then sum up to get the pixel values. Now upscale the chrominance channel. Then after change the color space from YCBCR model to RGB color model. Then display the uncompressed image on our computing devices. So, let's discuss the many advantages of JPEG file format. These are: first, file size reduction. This is particularly important for image that are intended for web uses, where a small file size lead to faster loading times and a better user experience. Second point is efficient compression. It efficiently removes redundant and less perceptible image data. It achieves this is by quantizing and compressing color and brightness information differently based on human visual perception. The third point is photorealistic image. This technique is well suited for photographs and image with natural scenes, gradients and complex color variations. It retains a good balance between compression and image quality for such content. Next point is compatibility. This ensures that JPEG images can be easily shared and viewed without compatibility issues. Progressive encoding, it supports progressive encoding, which allows an images to be displayed at progressively increasing level of all details as it being downloaded. Like any technology, it has its limitations. Here are some of the limitations of JPEG format. The first is lossy compression. The result of this algorithm is a loss of image quality, especially in the area with fine details, sharp edges and subtle color gradients. The second and big drawback of this compression is artifacting. The lossy compression used in JPEG can lead to compression artifacts, which are visible distortion or noise in the image. The common artifacts include blackiness, blocking artifacts, and blurring of edges and details. Third is limited transparency support. This algorithm does not support transparency. Images with transparent background are better suited for formats like PNG and GIF. It has limited color depth because it supports only 8-bit color depth per channel. This is generally sufficient for most photographic images but may not be suitable for images that required very high color accuracy or depth. It is not ideal for text or line art because it is not well suited for images with sharp edges, text, line art, as these types of images can exhibit no more noticeable artifacts. It has limited metadata, but it may not be as robust as some other file formats like TIFF or a RAW file in terms of storing. Susceptible of generation loss. If you open a JPEG image, make edits and then save it again as a JPEG, you introduce generation loss, meaning the image quality degrades further with each subsequent save. The next drawback of this technique is compression efficiency trade-off. JPEG compression involves a trade-off between file size and image quality. Adjusting the compression level can lead to their smaller file size with more noticeable artifacts or better image quality, but the larger file size. With these advantages and limitations, it is particularly well suited for photographs and other images with complex color variations and details. Let us list out some common application areas of JPEG format. The first is in web images. It is most common image format used on the internet. Second, digital photography. It is the default format for most digital camera and smartphone photographs captured by these devices are often saved in JPEG format. The third is social media. These images are commonly used on social media platform due to their reasonable image quality and smaller file size. This enables faster uploading and downloading of images on the platform like Facebook, Instagram and Twitter. Fourth application area is email attachments. If it is suitable for sending images via email attachments, since the compression help reduce the size of images, making them easier to send the receivers. In the online advertisement, it is also used for online advertisement as they provide a good balance between image quality and load times on the website and advertisement. In the e-commerce platform, online shopping websites uses JPEG images to display product images. This allows customer to see product details without significantly affecting the website's loading speed. The next application area is digital art and design. It is sometimes used in digital art and design products where a balance between image quality and file size is important. It is commonly used for online portfolios and digital art platform. On the printing designs, while this format is primarily designed for digital display, it can also be used in print design for materials like brochures, flyers, especially when a large file size are not a concern. And last is archiving. It can be used for achieving images that do not require lossless compression. However, the long term preservations format with better lossless compression like PNG, TIFF might be preferred. Now, I would like to summarizing the steps of JPEG compression. The first step is to convert an image's original color model from RGB to YCBCR and just pick the Y channel and break into 8 cross 8 blocks. Then starting from the first block, map the range from minus 128 to plus 127. After that, you have to find the density of the matrix. The result of this should be quantized. The last step is to apply encoding in zigzag manner and do it till you find all the zeros. Save this one-dimensional array and you are done. Note, you have to repeat this procedure for all the block of 8 cross 8. Understanding the basics of JPEG compression is essential for everyone, those who are working with digital images, from student photographers to web developers, as it influences how we store, transmit and display visual information in the digital age. Thank you. Looking forward to seeing you in the next video or whenever you need support. Have a great day. Goodbye.